So earlier today I saw this video about bijection. And the claim was that this was like this really important thing and it's critical to understanding anything like counting. No, you're fucking stupid. So yeah, the idea here is you have, say we've got like some things, right? And we want to count them, and I don't know how many there are at this point, I'm just keeping doing it. And I'm just going to delete a random number, and there we go. I really have no idea how many this is. So now if we count these off, we get 1, 2, 3, 5, 6. There we go. And now there's a bijection there because there is as many things as there are numbers. There's a problem with this, though, because allegedly 0 is a number. So where the fuck does 0 fit in here? Is 0 one of these things? No, it isn't at all. It is the starting point. That is what 0 is. But 0, well, it's not a bijection now. Clearly, because there's fucking nothing there. That's empty. That's just an empty space right there. That's not what I was trying to type. There you go. There's nothing there. So if 0 is a number, then clearly this is not a bijection of the numbers onto the objects. And then you have problems like, well, allegedly things like exponents are supposed to be iterated multiplication, right? Such that like 3 squared is multiplication by 3 twice, but we get confused and we say it's 3 times itself twice, or we get confused and we say it's 2 3's multiplied together. Both of those have to be wrong, because if you had 3 multiplied by itself twice, you get this, and if you have 2 3's multiplied together, you get this. Neither of those are iterated multiplication. One of them has too many 3's, and one of them doesn't, and the other one, the one that is currently on the screen, does not have enough multiplications. So clearly we have a problem here, and it should be this, but we're fucking retarded and we can't understand that. Yeah. So if we actually take the words for it, I'm going to leave it here on the screen as this, because that is actually what it is supposed to be. It is supposed to be based on what people say. 3 squared is either 3 times itself twice or 2 3's multiplied together, and those are both wrong. It really should be, exponentiation should be iterated multiplication, such that 3 squared equals 1 times 3 twice. Now, the 2 actually means something. We get 2 multiplications. The 3 means something. It's the base that we're getting, that we're multiplying by 2 times. That is what it should be doing. But now you run into a problem, because capital Pi notation allegedly allows us to iterate multiplication, right? So now you've got, how do I type this? I don't know how to type a capital P. I'll just write it as a capital P in English. Okay, so this should be a capital Pi. I don't have a key for that. I'm not gonna fuck around and figure that out right now. Anyway, so whatever, how the fuck ever you want to write this. So we've got like I is 0 to infinity or some bullshit, right? And we're just gonna do I. Okay, so there you go. Now you're just multiplying like all of the whole numbers together. Well, all of, starting with 0, right? All of those. What if we go negative infinity to infinity? There you go. Now you got all of them. There's a problem, though. There's a problem here, because the 0th multiplication, this can't map to exponents, right? So like n to the 0 should be the 0th multiplication, you spell that? And we just do this, the 0th multiplication. But n to the 0 is 1. This isn't... That's going to be 0. Actually, it doesn't matter what this is. This could be infinity. It's still going to be 0. So capital Pi notation doesn't give us iterated multiplication. Exponentiation doesn't give us iterated multiplication the way that it's normally thought of, because nobody knows how the fuck to raise to the 0 power, right? Or what about like 3 to the -1? That should be a third, right? How do you get that with this? How do you get that with capital Pi notation? You can't fucking do that. So there should be a bijection there between exponents and capital Pi notation, but you can't get that, right? That doesn't fucking work, because fundamentally bijection is incapable of handling counting. That is not how it works. 0 is special. 0 is different. 0, it's not a number. It actually isn't. It's, you want to call it a number, but number spaces have 0. Right. Dimensions have 0 in them. 0 doesn't have the dimension in it, right? So the number space is not... There's nothing there that is a property of 0. The existence of 0 is a property of the number space. This is a very important thing. And 0 precedes any of these, and that's important for understanding how exponents actually work in the first fucking place, right? If you want to properly understand exponents, you have to be able to go back to the very beginning of everything, when you have nothing. Like, literally all that exists is 0 and 1, right? So this is nothing. This is something. Those are the only two things that you have. And once you operate upon this 1, then you get things like dimensions, numbers, fractions, irrationals, positives, negatives, that's dimension, imaginaries, positive and negative imaginaries, the quaternions. So you get not only the negatives, which is the fundamental unit of the reals, as you can see if you look at any chart of quaternion multiplication, but you also get I, j, and k, which are the fundamental units of those other dimensions. And the inverse of -1 is +1. This is not +1. This is simply 1. Right? This is simply existence. This is simply non-existence. There is no space between these. This is not a successor to this, right? So Peano's axioms don't operate here, and once we do anything to this and we build up a number line, Peano's axioms are no longer reasonable, because the successor to 0 now becomes L0, because we get this. It goes from 0 to L0 to 2 times L0. We have an infinite number of stages, and then we get to like what you would normally think of as like a monad, like 1 on infinity. Like what you would normally think of there. But like, this could be anything. So like we say 1/6, or 1/5, 1/4, 1/3, 1/2, yada yada yada. It just keeps going on, and there's, obviously there's infinite steps in between these things. And actually here there aren't. There's literally nothing between these two, or these two. 2L0 is the successor to L0, and L0 is the successor to 0. And then eventually we get to 1. So Peano's axioms don't work here, because why is 1 the successor to 0? Isn't 1/5 a more valid candidate? It's closer to 0. Isn't 1/6? Right? But there's an infinite number of steps between anything up here and anything down here. So Peano's axioms don't fucking help us. Like, you're fucked. You can't do this. Alright? Set theory doesn't work for math. Fundamentally. Like, bijections don't work. They're not useless. It does, like, explain some of your intuitions, but it also fucks you up, right? So, like, when you ask a little kid, like a little kid that hasn't seen this before, to do something like count from 3 by, well, just count from 3 up to, I don't know, 8 or something. What they will do 100% of the time is say 4, 5, 6, 7, 8. That's what they will do 100% of the time. And they're not wrong. Because what they're doing is this. They understand that when you count from 0. So the first thing you say is the number after that. That's what they're doing. So when you're trying to make a claim that you need bijection to understand counting, you're fucking wrong. Because it doesn't work that way. It fundamentally doesn't. The bijection occurs after the starting point. It doesn't include the starting point. Okay? You have to set a starting point, this is true, but that is not part of your bijection. So the bijection is trash. It's not giving you the full story. It's giving you a partial story. So having faith in it is kind of fucking stupid. But that's where we're at right now. I mean, we live in a world where this is actually how exponents are explained. Right? Here, the wording for this would be 3 times itself twice, or here, 2 3's multiplied together. But at the same time, you're claiming that that's iterated multiplication. If it's iterated multiplication, then you should have 2 multiplications by 3, but it should be equivalent to, numerically, computationally equivalent to 3 times 3. Which means that you have to start with 1. 1 times 3 times 3, that is 3 squared. That is 3 with 2 multiplications, or 1 with 2 multiplications by 3, which is iterated multiplication of 3 2 times. That is what that is. And that means that anything to the 0 power is 1 always. Doesn't matter what the base is. Doesn't come into fucking play. Because when we're doing that, we're starting here. There is no number line. There are no numbers, actually. It is 0, non-existence, and 1, existence. Dimensionless 1. There are no details appended to this yet. It doesn't have... It's not a vector. There's no directionality to it. There is no scale to it. There's nothing between it and 0. There is no shades of gray of existence here. It's just either there's something or there's nothing. That's all it is, right? That's where this is at. That's where you have to start, right? And that's why that 1 appears when you take a negative exponent. You get a 1 as the numerator. Where does that 1 come from? It didn't come from thin fucking air. It came from right here. It's this. It's that 1 that precedes the existence of numbers. Because it's iterated multiplication, and if you step back and understand what that means that in order to take an exponent, you have to start from the beginning when there's no math yet, and then work it up to the point where you get the solution to your exponent. Every single time that's what's happening, right? 17 to the third doesn't know anything about numbers until we get to 17 to the first. Well, 17 to the L naught. As soon as you step past 0, right? That's the proper successor there. But it's a lot easier to conceive of 17 to the first. So I'll say it that way, and just because clearly everyone is retarded, so let's just make it slightly easier on you. This isn't complicated, it's just that you've been explained very stupid things by very stupid people who don't know what the fuck they're talking about, and you never stop to think about it, and you think you're right, and you're not. So yeah, no, bijection is a problem. Bijection doesn't work. Set theory does not work to explain mathematics. It just doesn't. You can't do that. Even a number line, it's not a set because 0 isn't a proper member of that set. 0 is something which precedes any dimension. Every dimension has 0, but 0 doesn't have any dimension. That's obvious, right? 0 isn't a vector. 0 is specifically the lack of a vector. But anything other than 0 is a vector. L naught is a vector. Negative L naught is a vector, right? L naught or positive L naught and negative L naught are in opposition to each other, right? They're so fucking small that you can't even perceive them. Other than when you're taking a limit and then you actually compute at that value. But fundamentally, they are so small that you can't even tell the difference between them and 0. They're so small that even the concept of monads doesn't work to explain them, because if it was a monad, there would still be space between it and 0. It is so close to 0 that there is no space between it and 0. It is very, very special. And this is, I think, as far as I know, it is a concept that has not been addressed in formal mathematics up to this point. But also, we live in a world where you fucking think that 3 squared is 3 times itself twice. So I don't care. You're idiots. Yeah, but those are vectors, right? Positive L naught, negative L naught, those are vectors. They're very tiny vectors, but they are vectors. As soon as you get off of 0, you're dealing with vectors. But at 0, it's truly magical. It is not a number. It is so much more powerful and more important, and nobody understands this. And it breaks bijection, right? Well, it at least requires us to, if we're going to take bijection seriously, it's not a sufficient explanation of anything. You have to have more than that, right? And that's what this is, right? If you want to pretend that 0 is a number, then you have a problem here. You have a problem in a lot of places.